Hi, welcome to Raw Math. Today I'm doing a series of videos on rationals, both expressions and equations. This video is specifically on equations. That means rational is a fraction, equation is an equal sign. The beauty about having a fraction with an equal sign is our first step can be clear the fraction. For my first example, I want to look at my denominators, and to clear my fraction I need to have something I can multiply to each fraction to clear it. It's a little bit weird because there's no numbers, but my least common denominator for this one is going to be x squared. I don't have to worry about the 1 here, which has a 1 in the denominator. If I multiply by x, this x will clear, but there'll still be an x under the 10. So I need to multiply by the largest exponent, which would be x squared. So if I multiply through by x squared, I'm going to multiply this x squared to each of my 3 terms. Very often I will tell you to start off by counting your terms. 1 times x squared is x squared. One of our x's cancel, leaving me with minus 7x, and both x squareds cancel, leaving me with a 10. Before I go on, I'm going to come back up to my least common denominator and note my domain is that x cannot be 0. I like to note my domain so that if I get to my solution and I have the answer of 0, I know it's not valid. I have a no solution answer. Okay. Subtract 10 from both sides. X squared minus 7x minus 10 equals 0. Now I need 2 numbers that multiply to 10 and add up to 7. Negative 10, negative 7. So if I look at this, I have 1 and negative 10. That would be negative 9, 2 and negative 5. That doesn't work. This isn't factorable. It's prime. Prime and no solution are not the same thing. If you get a problem that's prime, we have to use the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative b, so negative of negative 7, plus or minus the square root of negative 7 squared minus 4 times a, which is 1, times c, which is negative 10, all over 2a. That's 2 times 1. So then I get x equals 7 plus or minus the square root of 49 plus 40 all over 2, or x equals x equals positive 7 plus or minus the square root of 89 all over 2. And that's where I'm going to leave it. I normally don't have a calculator when I do these types of problems, so I'm going to leave it there and be happy that I have an answer. When I have such a complicated answer, my domain was completely useless. My domain is usually based on factorable pieces, and in this case, an irrational answer, though it is a solution, is not a restriction. Okay, the second problem I want to work on, this is a lot simpler. Well, I guess not. They both have a really simple least common denominator. My least common denominator on this one is a plus 1. There's only one denominator to look at. And my domain is a cannot be negative 1. If it were, I would get a 0 in the denominator, and that's undefined. Okay, I'm going to multiply each of these terms by a plus 1. A plus 1 and a plus 1. In my first fraction, the a plus 1's cancel, and I'm left with a. A plus 1's cancel. I'm left with plus 3a plus 4 equals 3 times a plus 1. Let's see. 4a plus 4 equals 3a plus 3. So you subtract 3a from both sides, subtract 4 from both sides. A, cancel, cancel, negative 1. A equals negative 1. A equals negative 1. A cannot equal negative 1. If you don't write the domain, as long as you check your work by putting that negative 1 back into the original equation and getting negative 1 plus 1 is 0, and a 0 can never be in the denominator, you're okay. but you need to do, well, we should always check, but having the domain is a little bit of a shortcut there. This has no solution. Awesome. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I will see you on the next video. Thanks.